Chandrayaan 3 is the spacecraft. It is the third most recent Indian lunar exploration mission under the Chandrayaan program of ISRO. It consists of a lander named Vikram and a rover named Pragyaan, similar to Chandrayaan 2. Its propulsion model would act like an orbiter. The propulsion model carries the lander and a rover configuration until the spacecraft is in 100 kilometers lunar orbit. Following Chandrayaan 2, where a last-minute glitch in the landing guidance software led by the lander crashing after entering the lunar orbit, another lunar mission was proposed. The launch of Chandrayaan 3 took place on 14th July 2023 at 2:35 p.m. IST. The lander and the rover are expected to land near the South Lunar Pole region on 23rd August 2023. The powered descent is scheduled for 23rd August 2023 around 5:45 p.m. IST, and the touchdown is expected on the same day around 6:05 p.m. IST. As part of the Chandrayaan program to demonstrate the soft landing on the moon, ISRO launched Chandrayaan 2 on-board a launch vehicle Mark III launch vehicle consisting of an orbiter, a lander and a rover. The lander was scheduled to touch down on the lunar surface in September 2019 to deploy the pragyaan layer. The European Space Tracking operated by European Space Agency will support the mission according to a contract. Under the new cross-support arrangement, ESA tracking support could be provided for upcoming ISRO missions such as those of India's first human space flight program Gaganyaan and the Aditya L1 solar research mission. In return, future days ESA missions will receive similar support from ISRO's own tracking stations. Objectives. ISRO has set down three main objectives for the Chandrayaan 3 mission, which includes number 1, getting a lander to land safely and softly on the surface of the moon. Number 2, observing and demonstrating the rover's loitering capabilities on the moon. Number 3, in-site observations and conducting experiments on the materials available on the lunar surface to better understand composition of the moon. Chandrayaan 3 comprises of the three main components. Orbiter. The propulsion module will carry the lander and the rover configuration till 100 km lunar orbit. It is a box-like structure with one large solar panel mounted on the side and the large cylinder on top that acts as a mounting structure of the lander. Lander. The lander is responsible for the soft landing on the moon. It is a box shaped with 4 landing legs with 4 landing thrusters of 800 newtons each. It will be carrying the rover and various scientific instruments to perform in in-sight analysis. The lander for Chandrayaan 3 will have only 4 throttle level engines with thrust valve slew rate changing capabilities, unlike Vikram on Chandrayaan 2, which had a 800 newtons engines with the fifth one being centrally mounted with the fixed thrust. One of the main reasons of Chandrayaan 2 failure, that is attitude decreases during the camera costing phase, was removed by allowing the lander to control attitude and the thrust in all phases of a descent. Attitude correction range is decreased from 10 degrees in Chandrayaan 2 to 25 degrees in Chandrayaan 3. Additionally, the Chandrayaan 3 lander will be equipped with a laser Doppler velocimeter (LDV) to allow measuring the attitude in 3 directions. The impact legs have been made stronger compared to Chandrayaan 2, and the instrumentation redundancy has been increased. It will target a more precise 4 km by 4 km landing region based on images previously provided on OHRC on Chandrayaan 2. ISRO improved the structure rigidity, increased polling in instruments, increased data frequency and transmission, and added other multiple software and contingency systems, as the lander is designed to withstand failed landing attempt via multiple complicated software simulations. Rover. It is a 6-wheeled design mass of 26 kilograms, that is 57 pounds, range 500 meters, that is 1600 feet, dimensions 917 millimeters. The Chandrayaan 3 rover is expected to make a number of important scientific discoveries, including the composition of the lunar surface, the presence of the water ice in the lunar soil, the history of the lunar impacts, the evolution on the moon's atmosphere.